Today, we are going to talk about something called direct variation. We are doing direct variation. Let's start out with what is direct variation. When two variable quantities have a constant ratio when two variable quantities have a constant ratio, their relationship is called a direct variation. When two variable quantities have a constant ratio, the relationship is called a direct variation. Now, we're going to talk about what all this means. We'll go through it, so don't panic just yet. What you should know, though, what we need to add on to here is that the constant ratio is called the constant of variation. The constant of variation. It is a single number, usually, and again, it's a ratio, so most likely it's going to be a fraction, absolutely. It is also known as, that's why I'm going to put AKA, also known as the constant of proportionality. Also known as the constant of proportionality. Now, believe it or not, this is nothing new. You've actually seen all this before. Matter of fact, you saw at the beginning of the week when we talked about rates of change, or constant rate of change. You saw it the last 2 days when we talked about slope. It's all related to each other. Matter of fact, in a direct variation equation, the constant rate of change or the slope, as we sometimes call it, is assigned a special variable. And this time, this variable we're going to make, let's see, what would you think? Constant rate of change, probably call it, I know, you're hesitant after that slope one, right? You know, slope being m, well, you're right, you should be a little hesitant. Because this time, it makes perfect sense to me. It's a constant. K. K for constant. Oh, okay. I don't know. C is used for other things in math, so they didn't want to use C for constant, so they used K for this instead. So K is our constant rate of change, or in a direct variation equation, the K is the slope. All right, so let's look at this problem, and I'm gonna type the question out to make sure it's a little easier here for you to read. And it says, the height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. Okay, so give you a second to write that down. The height of the water as a pool is being filled will be shown in the graph below. Determine the rate of inches per minute. And I'm going to pause the video you should pause the video so that you can finish writing that down. So now, here's what the graph looks like. Make the graph, and we're going to go 5, 10, 15, 20, 1, 2, 3, 4. We're going to make it kind of simple here. And we're going to draw a line. And this is going to be the point. Oh, you know what? Sorry. Change that. Change these numbers here. I'm sorry. This should be 2, 4, 6, and 8. So this is going to be the point 5, 2. And then we're going to have the point 10, 4. Is that okay?
Yeah.
Get it? 10, 4. Is that okay?
Oh, yeah. I get it.
Oh. Hopefully the other classes will laugh at that.
I don't get it.
15, 6,
No.
and 28. Okay. The x-axis is the time. And that's the time in minutes. And the y-axis is going to be the height. And that's the height in inches. Now, the trick here is we want to determine the rate in inches per minute. Now, we could do this in one of two ways. We could look at this just as a constant rate of change, or we could look at this from the perspective of the slope. Well, let's start with doing this as a constant rate of change. So let's look at each point. And we're looking for the rate of change. And here, the first ordered pair we dealt with was what? What's the first ordered pair on there?
5, 2.
It was 5, 2. Okay, oops, 5, 2. What is the rate of change then? Or what's the rate, I should say? Not so much rate of change, but what's the rate? And remember, we're looking at inches per minute. So what should the rate be? Huh? 2 over 5. What was the second ordered pair?
10, 4.
It was 10, 4. So what would be the rate?
2.
It would be 4 over 10, but what's 4 over 10?
2 over 5.
It's 2 over 5. You seeing the pattern here?
Yeah.
All of the rates are going to be the same. Now, if we look at the slope of the line, the slope, let's take the 2 points we have written down here, 5, 2, and 10, 4. Which of those points do you want to call x1, y1?
5, 2.
Here's x1, here's y1, here's x2, here's y2. So the slope then is going to be y sub 2, which is 4, minus y sub 1, which is 2, over x sub 2, which is
10.
minus x sub 1, which is
5.
okay, what's 4 minus 2?
2.
2. What's 10 minus 5?
5.
5. And the slope is also 2/5. So in a direct variation, your rate of change, or your rates, your slope, all going to be the same. And that is actually the constant of proportionality as well. Okay?
Wait, so isn't K 2/5?
K would be 2/5. Absolutely.
So the rate of change, or direct variation and the slope are the same thing? Basically?
They are, yes. In this case, they are. And that's how you tell if something is a direct variation.
Well, doesn't the question say determine the rate of inches per minute, I guess?
Inches per minute, right. Remember, the y-axis is the inches, and the x-axis was the minute. And so inches would be y over x. So it would be, that's why it's 2 over 5, because I want the y over the x.
Yeah, but is it per meaning
You know, you could say that, but even if we took this and went out of 1, each of these would still be 0.4. They will each be 0.4, because that's what 2/5 is. It's 4/10. Right?
Yeah.
So it's still all the same. I like leaving it in terms of the actual slope, because that's going to come in it's going to come in handy later. Okay. So, if we're talking about the equation of direct variation, so we're talking about the equation of direct variation. When I'm looking at the equation of direct variation, the equation is y equals kx. The equation is y equals kx, where k is the constant of proportionality. Yes? So if I gave you the equation y equals 8x, what is the constant of proportionality here?
8.
It's 8. It is also the slope of the line. So 8 happens to be the slope of the line. So if I had graphed y equals 8x, 8 would be the slope, would be how steep that slope is. Simple enough?
Yeah.
Okay. Now, let's look at this particular topic here. So let's talk about how to write equations, or how to find information based on the equation. So take a look at this question here. If y equals 14 when x equals 8. If y equals 14 when x equals 8, find y when x equals 12. Now, there are a few ways that I could do this problem. I'm going to show you one of those ways today. You will learn about other ways later on. But today we're going to focus on the way of using the direct variation equation. Okay? So here is step 1. Step 1 is use the given information to find k. So the first thing I want to do is find the constant of proportionality. I know that y equals kx, correct? Am I given a y and an x that I could use? What am I given?
14.
I'm given 14 and 8. So I'm going to plug that into my equation of variation. 14 equals k times 8. Right? Does that work? Yeah. How do I solve for k? What do I do to solve for k?
Divide both sides by 8.
Divide both sides by 8. Divide both sides by 8. Okay, so those 8's cancel out. That's good. That gives me k. But now I have 14 over 8. Can I leave it that way?
No.
No, what should I make it?
Decimal.
No.
A fraction.
Fraction. Well, it's already a fraction, but what's wrong with this fraction?
Reduce it.
I have to reduce it. What is 14 over 8 reduced? 7 over 4. So now that I've got my constant of proportionality, I'm going to use the direct variation equation to find the variable. And I'll show you what I mean by that. I'm again going to use y equals kx. Do I know what y is?
No.
No, because that's what I'm trying to find, so I'm going to write y down here. Equals, do I know what k is?
Yes.
What's k?
7 over 4.
It's 7 over 4. I'm getting my k from here. Times, do I know what x is?
12.
X is 12. Because I'm told x is 12.
Didn't it say it was 8?
Well, no, I was given that. Now I'm trying to find y when x is 12.
Oh.
Now, y equals 7/4 times 12. Does 4 go into 12?
Yeah.
How many times?
3.
3. And what's 7 times 3?
21.
So y is equal to 21. So if y equals 14 when x equals 8, then y is equal to 21 when x equals 12. Here, let me give you one to try. Would you please try this one? If y equals 6 when x equals 30, find y when x equals 15. Okay, I'm going to pause the recording, or you're going to pause the recording, and try this problem. Okay, let's take a look at how we do this one. Again, I'm going to start by trying to find k, right? So to find k, what equation should I write down? To find k, what equation am I going to write down?
Y equals kx.
I am going to use y equals kx. That is true. Y equals kx. Can I fill in any of the information? Like if I'm trying to find k, do I have the y and the x?
Yeah.
What are y and x? Yeah, because I'm given that. That's what's given to me. So I can go 6 equals k times 30. Okay, how do I solve for k? Divide both sides by 30. Good. Divide both sides by 30. And so what is k? K is 1/5. Now, I want to go to find what, now I want to find what y is. So should I use y equals kx again? Yeah. I use y equals kx, but this time, do I know what y is? No, I don't know what y is. Do I know what k is? Yeah, the k is going to come from down here, and I'm going to put it into there. So that's 1/5 times, do I know what x is? X is equal to 15. Okay, so y equals, what's 1/5 times 15? 3. How many people got y equals 3? Good. Now, I'm going to change this up on you. Try this question for me. Find x when y equals 14 if y equals 7 when x equals 8. Try this one, please. Stop the recording and try it. Okay, so let's take a look at how this one works. Now, this one's a little different. Out of curiosity, what did you get?
X equals 15. X equals 15.
Okay, variety of answers. Let's see. I'll start with y equals kx. I'm going to use what I'm given. Y equals 7 when x equals 8. I'm given both my x and a y because I need to find my k. So I'm going to go 7 equals k times 8. Divide both sides by 8. We know that. And so k will equal 7/8. Now, I'm going to use my y equals kx again. And I'm trying to find x when y equals 14. Aha! Y is 14 this time. K, well that's 7/8. Do I know x?
No.
I don't know x this time. So now, let's see who remembers. How do I solve 14 equals 7/8 x? How do I solve this? Who remembers how I solve this?
Simplify 7 and 14.
Huh?
You could simplify 7 and 14.
No, you gotta be careful of that. There's a special way you do this. Good. I multiply both sides by the reciprocal, 8/7. Multiply both sides by 8/7. That way here, those cancel out to give me the x. Now I could do my thing again. Does 7 go into 14?
Yeah.
How many times?
2.
Twice. And what's 2 times 8?
16.
16. So x is equal to 16. Okay. Questions? All right. That finishes the notes for today.